All right, so this is your notes for today. We're going to be doing 2.1 and 2.3. Okay, so 2.1 and 2.3. And here we go. Today is 03, the 11th, 03/11. Again, pause if you need to. Pause if you need to. Okay. All right, moving on. We've got March 11th, and our homework is going to be additional practice and the AFQ for AFQ for 2.2, and we're going to do page 55. Due on the 203/13. Okay. Again, pause if you need to. All right, so jumping right into it, just a reminder, you have a quiz coming up in a little bit over a week and a half or so. In about 8 days, so not a week and a half, 8 days. Okay, so we're going to jump to page 2.1. Let's see what it looks like. So surface area and volume of a prism. So here are the definitions for prism. And actually I'm going to go to period 3 because theirs is already done. So period 3. And I'll have this copied and pasted for you guys as well. So a prism is a solid three-dimensional figure whose ends or the faces are equal. So at one end it's the same shape as the other end. Okay. I drew some figures there for you, so if you're not sure how to draw them, you can follow along. I'll erase it and redraw it. So I just start off with the same figure. So I'll start off with my triangle. Okay. And I'm going to draw the same triangle. I'm going to try to draw the same triangle at the other end. So these are my bases. Okay. These are my ends of my figure, and I'm going to connect them top to top, bottom left, and dotted lines just behind. There you go. I have my prism. Okay. A net is an unfolded three-dimensional figure. Think about your virtual box when you open it up. Okay. I do have some cutouts here so you can see what they look like. So here is that net of a three-dimensional figure. So if I fold it up, I end up with a three-dimensional figure, and the ends are the same. This end is the same as this end. This is not an end, and that's not an end, because these sides need to be the same all the way through, and they're not. Whereas here, if I have a prism, I have a triangle on one end, and then here I should have a rectangle that goes all the way across. Okay, so think of like a Toblerone bar, something like that. Okay. A face is any one of these sections. Okay. So when you unfold it, one face represents any one section. Any flat surface of a geometric solid. Geometric solids are referred to as prisms usually. It's a 3D shape. Right. A lateral surface area is that section in the middle. So here I have my triangle prism. This middle section is my lateral surface area. I have a hexagonal one. This middle area is my lateral surface area. Here, not the ends, but the middle section is my lateral surface area. I think that's all my shapes. Pentagon, hexagon, triangle. I have all the same, two triangles. A square. All right. So any of those sections are going to be, any of that middle section is a lateral surface area. And your equation for lateral surface area is the height times the perimeter of the base. Okay, so to find the surface area of any of these shapes, okay, this is my height here, and this is the perimeter of my base. I'm going to multiply those two values. Height here and perimeter of base. Okay, and the reason why it's perimeter of base is as I fold this, the base will go around. It'll go around, and it'll eventually be the same as my distance across. Sorry for the poor video. This is just what I had on hand. All right, moving on. Provided a piece of looped string. So instead of a looped string, what I'm going to do is I'm going to show you using my prisms. Okay. So you're going to find the area of the surface area, the lateral surface area, and the area on the top and the bottom, and the total surface area. Okay, so this is the main goal of the idea. Okay, I have a triangle here. I have a square, and I have a pentagon, and I have a hexagon. What I'm going to do is I made these, and I made them all with the same lateral surface area. So I'm going to line them all up. Okay, and what you'll notice is the lateral surface areas, this middle section, okay, it's all the same size. I made them so that they're all the same. Okay, so this middle section is my lateral surface area. Okay, lateral surface area. Good. Actually, I'm going to go ahead and write on this so you can see what I'm talking about. This middle section is called my lateral surface area. Lateral surface area. Okay, that lateral surface area is determined by this value here from this end down to this end, and I call that the height. There's my height. Okay, times the top, which I call the, well, I just call it, it's called this section here, length times width, or height times base, whatever you want to call it. This, the length laterally across, this is called this is the perimeter of the base. That's the perimeter of the base. Okay. Now the perimeter of the base is defined by this section. This part is just as long as this part. I'll call that section 1, section 1. As I go around, this section here, call this section 2, is this part right here. From here to there, that's section 2. So I go around. This one I'll call section 3. I'll call this section here section 3. As I go around some more, this section, that's section 4, they'll match up. So when I go all the way around, 4 will match up with 4. Okay. And then this section over here is going to be section 5. And that's going to match up with this section over here. From here to here, that's section 5. And the last section is section 6. So when I wrap this base around the lateral surface area, they'll match up. 5 will match with 5. 2, 3 to 3, 4 to 4, 5 to 5. It's kind of hard to see. And then 6 to 6. Okay, be almost impossible to see unless you look inside. There you go. That works. 6 to 6. Okay. Now, if they all have the same lateral surface area, so I'm going to place them on top of each other again. If they all have the same lateral surface area, this middle section is all the same, which one's going to have the greatest area? Now there's my triangle. The only different part is going to be this base. I have my triangle there, and then now I have my square here. Which one covers more space, the triangle or the square? Okay, let me outline this triangle so you can see it a little better. Okay, here's my triangle. Okay, there's my triangle. Which one's bigger, triangle or the square? Well, this little piece looks like it fit there, but this square is much, much larger than the triangle is. Okay, so same lateral surface area, different base. The square is definitely larger. Now, what's happening as I go from triangle to square is I'm only increasing the number of sides. Okay, the lateral surface area stays the same. Okay, so there's my square. Square is definitely bigger. Okay, so I'm going to compare my square to my pentagon. Okay, which one takes up more space? As I gain more sides, my pentagon gets more and more area. These little square pieces, they're not very big, and these parts of the pentagon are definitely much larger than the other one. Okay, so I'm going to keep the square. I'll keep the pentagon because the pentagon's bigger. Okay, here we go. Outline this. All right, there it is. Okay, and as I go from pentagon to hexagon, what you notice is you see more hexagon peeking through. The hexagon is the biggest one, and we can say as we add more sides, let me start. I'll put them all together so you can see them. Okay, same lateral surface area, same middle section. This is all the same. All my edges are lined up. Okay, as I gain more sides, I get more and more surface area. Okay, so I'm gonna write that down here on in your notes. Okay, so we're gonna skip this section for now. We're gonna answer question number 1. As the number of sides increase, what happens to the total area? So I'm gonna say the total area the total area will increase as the number of sides in the base or bases increase. Okay. Now, to describe the strategy for finding the surface area of a prism or the net, okay, it's broken down into basically 2 parts. Okay, so I can just draw a quick drawing. Okay, this is my net. Okay. This part here is my LSA. Okay, that's my lateral surface area. I'm going to abbreviate that off to the side. LSA is equal to lateral surface area. Okay, and I'm just going to do a quick sketch, maybe it's the triangular one. Here's my triangle. I think I need to make it a little bigger. That looks about right. Here's my triangle. Okay. Here's my lateral surface area, and these are my bases. Okay, and we drew this out already, so I'm gonna draw it out one more time. This is my height from here to there, and this is my across the other way. I'll do an orange this way. This is my, actually, you know what, blue would make more sense. This is my perimeter of the base. Perimeter of base. So here's our equation. I need the red section. I need this red section here, LSA, and then I need two bases, base and base. Okay, so I'm going to write that out. Here in red is area LSA, LSA plus 2 base. Okay, so I'm going to write the equations right underneath it. My lateral surface area is going to be height times perimeter of base. That's LSA. I'll do that. And then I'm going to find the area of the base times 2. I'm going to double the area of the base. And all that should equal surface area of prism. SA is surface area of prism. Surface area of prism. Now, this is unlike, it's not very much different than finding the surface area of a rectangular prism. This just includes things that are triangle-based prisms, hexagon, pentagons, anything that's not a rectangle, even though this same formula will work with a rectangular-based prism. Okay, how does the volume of a prism compare as the number of faces in a prism increase? Okay, well, let's find out. If our equation for volume, here's our equation for volume, okay, our volume is going to be area of base times height. Then if this number increases, if this number gets bigger, then my volume will also get bigger because my height doesn't change. Okay? So how does the volume of a prism compare as the number of faces in a prism increase? So volume should also increase because area of base increases. Again, pause if you need to. Make sure you write this down. And if we get confused, we can always review it when I come back. All right. That's the end for 2.1. So if you need to see it, it'll be online. I'll copy and paste it for period 3 and 5 as well. I guess we can skip this section because we don't have string that I already measured for you guys. So we're going to leave this part blank for now. So don't make it for now, just put a line through it in light pencil, please. Don't cross it out. We might have time to do it later. Okay. That way we know when you want to check your notebooks that those are supposed to be blank. Now's a good time maybe to take a few minutes, look over your focus question, and make sure that you have all of your vocabulary words filled out correctly. Please try the drawing as much as possible. Okay, 2.2 says calculating the volume of a prism. So here are your new vocabulary words. I know this a lot. Sorry. Try your best to do the drawings as neatly as possible. Again, it's not an art class, but it does help with understanding. Okay. A prism, a regular prism is a prism who has a regular polygon as a base. That means the base is either going to be an equilateral triangle, a square, equilateral pentagon, or hexagon, whatever it might be. Okay, this is the base we're talking about right here. Okay, so the base changes based on the type of prism we are looking at. A right prism is talking specifically about the base meeting the lateral surface area at a 90-degree angle. So I used the same drawing, and I made sure that there was a marking for a right angle meeting the lateral surface area. The lateral surface area I'll highlight in this wonderful brown color. Okay. So that's my lateral surface area, the part in between the two identical bases. And that lateral surface area, those should all be the same. They should all be rectangles. Okay. The lateral surface area should all be rectangles. Okay, volume is a little bit of a review. It's the amount of space an object occupies. You can think about it as the number of blocks in a figure. How many cubic inches or cubic feet are in a certain amount of space? It's not flat. It's always three-dimensional. Okay, so we talk about your area being. Your volume being the area of the base and then multiplied by the height. So you find that bottom section, how many will fit in that bottom row, and then you count how many rows up there are. Again, take your time, draw it neatly as you can. Okay, so it suggests using a VirtualBox or manipulative cubes. I'm not here, so if your sub feels comfortable